I'm CK. The other day we took a look at an inexpensive digital microscope, and it was so-so. You can look at that video. But as part of that, it had a power supply with it, little USB power supply, that as I looked into the connector, it looked kind of flaky. So what I'd like to do tonight is take it apart and see whether it is as bad as I think it might be. Again, the digital microscope was $60 with an aluminum base plate and rack and pinion column to raise and lower it, plus everything that goes into the microscope. How much can be in here? We'll take a look. I might be wrong. So let's see what's in this power supply. Again, it's power supply that went with a $60 product. So how much did they spend on the power supply? That's a real question. How much would you, if you were manufacturing this, how much would you devote to the power supply? So it's a AC-DC adapter, model 0520, universal, so it's 100 to 240 volts, 50 to 60 hertz. Output is 5 volts at 2 amps. We'll see about that. I mean, I don't have a USB load tester handy, but very few of these actually can sustain 2 amps, but we're not going to test it, so it doesn't matter. It's got all your typical service markings. Then interestingly, it's got a diagram for the connector as if it has a barrel connector on it, because it's showing the tip is positive and the sleeve is negative, but this is USB, so I don't know what maybe it was just a sticker that they had handy, who knows. So first I'm going to peel this sticker off just to see if there's any screws in here. Nope, no screws. So it'll just crack open. I don't know if it's ultrasonically welded or I need something thinner than that. Don't know if it's ultrasonically welded or glued. Ah man, I'm tearing the plastic up already. Didn't really want to do that, but that's okay. Well, it's obviously not glued or welded, but I'm not having a good time getting this sploger in here, but I'll keep trying. Come on. There we go. Well, that's interesting. It looks like it's got nice tab and groove, which is pretty good. So I'll pull it all the way apart here. Come on. Okay. So our first look. This wire coming from the main source. Very thin. I mean, that's a 20 or 22 gauge. So you're sure not going to handle, not going to handle a ton of current with that, but let's go ahead and pull this out and get our first look to see if it's too Frankenstein-y for words or if it's good. It's got some lettering inside, BXJ H388 mold numbering or something like that. Now we'll look at it. Now, I'll be honest, I was looking for something a little more dodgy than this, but this looks pretty good. Let me flip it over. Yeah, this circuit, look, the solder joints are all very nice. Right here is the gap between the primary side handling the main current, main voltage, and the secondary side, which is feeding the USB connector, and there's a lot of space between the traces. That looks like it'd suit any regulator or specification, so that's very cool. Then when we look at the components themselves, first thing that strikes me is usually these power supplies either don't have any circuit protection or use inexpensive fusible resistor, but this this has got an actual glass capsule fuse. I haven't seen an actual fuse in one of these inexpensive power supplies. And bridge rectifier, snubber circuit, the switching control for the power supply. Let me see if I can get a number for you. It is a CSC 7203. I can't tell what the manufacturer is. Looks like ISC, but I wouldn't swear to that. Then smoothing capacitor, auxiliary capacitor, and then there's the opticoupler, resistor, another diode, and then here's a big honkin' diode for this side, for the secondary side, and secondary capacitor. Looks like it doesn't have some things. It doesn't have, there's space for an LED. It obviously doesn't have one right now. A couple more resistors. I don't know what those would be for, and another small cap, similar to probably this one, which I think is, this is a 10, it's either a 102, no, it's a 104, so what is that, 0.01 microfarad, something like that. Looks like it's got space for another one on that side. This is the, it's got some sticky foam here. I don't really want to pull it off because I think it might hurt the capacitor. Capacitor from the primary to secondary side. I think that's the only component here that could be at all suspect because it doesn't look like a safety cap. But other than, and the transformer looks good. So set that down again, and we've got a real fuse, we've got quality components, the circuitry, the circuit board traces are well laid out, they're broad so they can handle a lot of current, more current than this could possibly ever produce. Got good spacing, so I am duly impressed. This is actually a heck of a lot better than I expected to see. In fact, I think I'm gonna put this back together and keep it and use it. I like this the design on this. So there you go. You come in with one set of assumptions, that you've got a inexpensive unit It obviously can't have all great parts, and then you take it apart and you see, wow, it does have some good stuff. I might come back later and put a load on it and test it, but I think I'm going to post this without this. So that's it. Instead of tearing into something that I thought would be horrible and we could make fun of it and we could take all the parts off and see how lousy they were, this is actually a good unit. I'm really happy to be able to say that. So enjoy.